Welcome to the class of Advanced Calculus and Complex Analysis. Today we are going to learn another important theorem in vector calculus, that is Stokes theorem. This is the statement of that theorem. Let S be the smooth surface which is bounded by the simple closed curve C, which is positive oriented, and F be a vector valued functions and having continuous first order partial derivatives. Then this LHS will be equal to RHS. This is the statement of the Stokes theorem. LHS basically the line integration and RHS actually the surface integration. So that means in this theorem it is saying, so this is line integrations will be automatically you can convert to the surface integration. Okay, so what about n? N basically it is the outward normal unit vector to the surface S. Okay, so let us try to understand that statement. So suppose S be a surface and C is the positive oriented curve and it is bounded, it is the boundary of the surface S, and AP is the vector valued function having continuous first order derivatives in this, so on this surface. So now what is n? N basically outward normal unit vector. N is the outward normal unit vector. So and suppose this is at any point, at this point on the surface S, then it is saying line integration will be equal to the surface integration in terms of the curl of it. So here this is the statement. By using these statements we are going to solve few problems. This is the first problems on Stokes theorem. This is saying by using the Stokes theorem to evaluate this one, basically line integration is given here. Okay, F also given, and what is C? C statement also it is there. It is the boundary of the triangle which vertex are there in the three-dimensional form, and it is also positive orientation. Anyhow, in the coordinates we have seen in the z values are 0 in each coordinates. Z is 0 here and Z also 0 here. You can see it here clearly. Z is 0, Z 0 and Z 0. So that means basically a triangle on the xy plane. So this is given in the line integration form. We are going to convert it to the surface integration by using Stokes theorem, and we will evaluate that surface integration. So that means what is that Stokes theorem? So let me write for this question. So it is by the Stokes theorems we know this C F dr, this dot product values will be equal to over the surface S and curl of F dot product with outward normal unit vector and ds. Okay, so here actually basically saying this LHS is there, you evaluate this RHS surface integration value. So curl of F, first of all we need to evaluate this one, you need curl of F and what is N and what is ds. These three things you have to identify, then only you can evaluate this surface integration. Okay, so we are going to evaluate that surface integration by using Stokes theorem. So that means we rewrite that integrations in terms of this notation, that curl of F, we know this one, it is over the surface S, and this is the curl of F and dot product with that unit normal vector and ds. Okay, so that means you have to calculate what is that curl of F. So that means this term you can calculate it here. So basically it is equal to, we know it is basically the determinant. Okay, so it is I, and what is that I component? It is given in the question. Okay, it is basically y square. Okay, you should write it here because here it will come. It is dou by, I am writing it, These are the operator, partial derivatives operator, dou by dou x. Okay, it is j, dou by dou y, dou by dou y, and it is k, that means dou by dou z. Okay. And here it is y square, it is the coefficient of I, and coefficient of j is x square, and coefficient of k, it is given minus x plus of z, x plus of z. Okay, it is given in the problem, right? It is the determinant of this one. Now if you solve this one, that means if you evaluate this determinant, you will get, it is j plus 2x minus 2y k. Okay, just simply 3 by 3 determinant you will have. Okay, you need it, but what about n and s? That things you have to evaluate. Just now actually for that one, to finding n and s, so basically you have to then draw the graph. What is the actually basically the triangle, that one you have to identify. As we have seen, z component is 0, that means it is actually the graph that the triangle will come on the xy plane, and it is the origin up to here. It is, suppose it is 1 comma 0. Okay, 1 comma 0, and for y it is 1 comma 1, because z component is 0. We are looking the graph on the xy plane only. Okay, it is the surface, and C is this one, surface S, and C is this one. C is positive oriented curve, positive oriented curve. Okay, so now what about Z? Z basically equal to 0. Okay, so then what is dz? Dz also will be equal to 0. These things you identify to evaluate this surface integration. So now then what about n? As I told you, n is the outward normal unit vector. So that means, look at the graph. Outward normal unit vector means along the z axis, and it is the upper. That means z basically the k along z axis, and it is in the positive side. Okay. So what about ds? It is that the graph is given on the xy plane. So that means ds is equal to dx dy. Fine. So these things we have identified. So now everything you substitute in this surface integration, then evaluate it, then you will get the correct value. Fine. So now I am going to substitute all these values in this surface integration. So what we are getting? So basically we are getting, this is the double integration, okay, and that it's 2x, that call of a value substitute, we got it, it is j plus 2x minus 2y into k. Okay, am I right? 2x plus 2 jk, and this is the call of a value, dot product with k, because n value is k, and it is dx dy, and over the surfaces. Now do this dot product. These are the two vectors. You see it is clearly showing. So this one and this one. Okay, two vectors are there. If you do the dot product, what will come? Only k components. Dot product is 1, and remaining it is 0. Okay, so that means you are getting, it is 2x minus 2y. You can do with respect to y and x by looking the graph. Suppose I am doing with respect to y first. That means y first means you have to draw a strip which is parallel to y axis, and accordingly you write the limits. So y limits are 0 to x, and x limits 0 to 1. Okay, so now you can easily evaluate it with respect to y. If you do the integrations, what you are getting, and again with respect to, so with respect to, first you do with respect to y, x limits as it is 0 to 1. Okay, so if you do with respect to y and substitute the limit for y, I am directly writing it will be x square. Fine, and it is dx. Okay, so now you do with respect to x and substitute the limit, you will get automatically it is 1 by 3. So that means by using Stokes theorem, it was a line integration, but we have converted to the surface integration, and the surface integration concept we have used. That means by finding the curl and then what is the outer normal unit vector and ds, and then we have evaluated this double integration, and that value integration value is coming 1 by 3. But suppose we want to see the whatever suppose if you solve this problem by using the line integration concept, then what will be the value? Basically we will get the same value 1 by 3. That means we are going to verify the Stokes theorem. To solve this problem, basically we are going to evaluate the LHS line integration value as well as the RHS, that means surface integration value. So by the Stokes theorem, what is the statement? Already we know. Just to write down the statement, that means left hand side the line integration f dr is equal to the surface integration form, that is s curl of f in ds. Okay, so this is the LHS and this is the RHS. So LHS and RHS to do that one, we have to find out. Suppose just now in the previous question we have done that RHS, that surface integration, we can start that one. Okay, so for that one you have to find out the curl of f and nds. So anyhow, so for that it is given question in the xy coordinates, so that means it is better to draw the graph in the xy coordinate. Okay, what is that rectangle? It is bounded by x is equal to plus minus a. A is a positive constant, any constant it here, and y0 and yb. So suppose this is x is equal to minus a and this is x is equal to a. Okay, so x is equal to a curve, that is the straight line, x is equal to a, and similarly the left side it is x is equal to minus a. So it is the straight line x is equal to minus. Okay, so now it is saying y is equal to 0. Y is equal to 0, it is well known. It is y is equal to 0 means it is actually the x-axis and it is the origin. And y is equal to b, another constant, positive constant. Y is equal to b, I am considering this is the straight line. Y is equal to b. Okay. So then what are the c? What is c? So basically it is the positive orientation curve. And what is that region? Region is this one. Okay, and you can say here it is the surface. It is the surface. This is the surface S and bounded by the positive oriented closed curve C. This is the C. Okay, so now actually on this surface and which is bounded by the curve C, we are going to verify the Stokes theorem. You can start the LHS or RHS. Just now we have solved that RHS, that surface integration. So let me solve that RHS first. You can do the LHS, but both the things will get same values, and that will be the verification. Okay, what is RHS? It is the surface integration S curl of f. Curl of f means in the symbol it is delta cross product with f and n ds. This one. So that this delta, if this curl of f you have to calculate. That means that delta cross f. That means you have to solve the determinant. Now what is the determinant? That is I, j and k. Okay, and it is dou by dou x, dou by dou y, dou by dou z, and the coefficients also you write down. It is x square plus y square. This one is the coefficient of I. Coefficient of j, it is 2xy, and coefficient of k is 0 because it is not given in the question. Okay, so 0 into k we can write. So that's my coefficient of k is 0. So if you do the determinant, you will get it is minus 4yk. Okay, minus 4yk. You can substitute it here. And the graph is given on the xy coordinate. So that means what is n? N is equal to k only. That is the positive oriented normal curve. And what is ds? Ds, then you will get it is dx and dy. Okay, so then what you are getting, that RHS value. So then now you will get the RHS value. So it is basically it is minus 4yk. Okay, minus 4yk into k and dx dy. Fine. Okay, dx dy. So but now we are going to write the limits. Suppose if you want to do x or with respect to y, so then accordingly you have to write the limits. Already we have seen, so how do you write with respect to y? Let me solve with respect to x also. There is no problem, anything you can do. For different ways I am doing, it is for your understanding. You can do with respect to y also. So x limits from the graph, it is the rectangle. That means limits are very simple, minus a to a. What about y? Y is equal to 0 to b. Y is equal to, so now, so do the dot product and do the integration. Then we are getting minus 4, okay, minus 4 y is equal to 0 to yb, and x is minus a to a. What you are getting here, it is y dx dy. This is a very simple integration. So you do with respect to x part and substitute the limit. Next with respect to y, and substitute the limit for y. What will get? Skipping this part, this is the homework for you. You can practice it. You will get it is minus 4ab square. It is your RHS value. Okay. So RHS value we got it. That means by we have evaluated that surface integration RHS. So now we are going to evaluate the LHS on the line integration concept. Fine. So now we are going to evaluate that LHS. That means that line integration. So that is C, and it is the dot product F dr. Okay, so what about C here? C base, if you just want to see that graph roughly here, so your rectangle was like this. What is C? C is the boundary of this surface S. This is C. So that means what is C? I can write it is the sum of the four sides. I am giving the name C1, C2, C3 and C4. Okay, so that means what is C? Basically it is the combination of C1 plus C2 plus C3 plus C4. So each sides will actually evaluate this line integration. So you can rewrite it for the better understanding. It is C1 plus f dot dr, okay, plus what about C2, and the same thing f dot dr, plus C3, C2, C3 f dot dr. You should write it here, and again, and C4 and f dot dr. You should write. Okay, now one by one along C1. So you can evaluate the integrations and substitute here. Suppose this is the equation number 1. So along C1, along the curve C1, what we will see? We can get what is x. X is equal to a. Okay, x is equal to a. Already we have seen the graph. So what is dx then? The dx will be equal to 0. Okay, dx is equal to 0. Now these things you can substitute. So therefore, what about this integration? So along C1, so that is f dr is equal to, so this one along C1 means the limits along C1 means this side. Look at the graph. This is actually this one C1. Okay, so that means y varying, y is 0 to b. We have seen in the graph, it is y is varying, y is 0 to b. Fine. And f dot dr, that one actually you can find out easily. So I am writing here what is f. It is given in the question. It is x square plus y square I minus 2xyj, this vector dot product with dr. Okay, and so there is no z component, so that means it is dxi plus dyj. Fine. This is the dot product of these two. So is it clear? So that means automatic. What if you do the dot product? So what you will get? Here you will here. So this is the rough work basically. So you do this dot product. So you will get it is minus 2ay. After substituting x is equal to a, you will do this dot product and substitute x is equal to a value. Okay, and x is equal to a value and dx is equal to 0. X is equal to a and dx is equal to 0. In this, that dot product you have to substitute it. Now you are getting this one and dy. So what is the value? It is minus, if you do this integration, ab square. So along C1 we are getting that line integration value is minus ab square. Clear? In the same concept. Similarly, so along C2, for this curve along C2 you have to evaluate. Clear? So that means along C2 what you are getting, y is equal to b. Then what is dy? Dy is equal to 0. So that means in that dot product you substitute these two relation, y is equal to b and dy is equal to 0. So then what is your integrations along C2? So along C2 you will get x is equal to a and x is equal to minus a, x is equal to a2 minus a, okay, and x square plus b square dx. Now if you do these integrations you will get minus 2a cube 3 minus 2a b square. Okay. So similarly along C3, along C3, so along C3 what you are getting, x is equal to, look at the graph, x is equal to minus a, then what is dx? If you do the derivative it will be equal to 0. So substitute these two values in that dot product. So then what we are getting in the here, so y actually starting from b to 0, okay, along C3. So here what we are getting, it is, so b2 it is actually starting from b to 0. B to 0, what that dot product and substituting these things you will get, it is 2ay and dy. So that means we are getting minus ab square to this integration. Clear? So similarly along C4, along C4 you will get y is equal to 0 x axis, and what is dy? Dy will be equal to 0. Okay, so then your integration is x is starting from, here x is starting from minus a to a, okay, and here it is x square and dx. So you will get 2a cube by 3. Okay, now that already along C1 we got that values, along C2, this is the value, and along C3 this is the value, and along C4 this is the value, and you substitute these four values in the equation 1. We are going to substitute this value in equation 1. So that means we will get, what is that LHS, that substitute these four values, that means ab square minus 2a cube by 3 minus 2ab square, okay, minus ab square plus 2a cube by 3. Okay, so we have substituted where? Substituted in equation 1. So you will get it. Then what you are getting? It is actually minus 4ab square. Okay, you are getting minus 4ab square. Already we have derived what is that RHS value, that is also minus 4ab square, and LHS value now we are getting minus 4ab square. Okay, so that means what we are getting, hence that LHS value is minus 4ab square, that is equal to the RHS value we have seen, that is RHS. Okay, so this is very important, the Stokes theorem for this problem. Thank you all.